So how will you maintain the record? You have to make the practical notebook separately. You can purchase practical notebook, otherwise you can make any notebook, either one side line, one side plain, that is better. Otherwise, both sides plain. If you are not getting, you can have any type of notebook. So what will you do? Just see this first activity. You will write Mathlab activity. Heading will be math. You can write together, or you can write on plain papers or line papers and scan and send to me. Mathlab activity number 1, class 10 Mathlab activity number 1. Okay. Then you will write the aim. Aim is this one, to verify the Pythagoras theorem. This is your aim. Okay. After aim, you will go to procedure. Here you will find materials required. Okay. After aim, you will write materials required. Yes, this link is OLab. OLabs. If you will write OLabs on Google, you can have this one. But this recording I will send you. You can see the recording. So aim, after aim, I told you that from where will you write? If you see this video I am making, you can see the video and write down. Okay. Then second point is your materials required. Okay. So materials required. Here you will write the cardboard. Do not use cardboard. Huh? So we are using the colored paper. So cardboard. Do not write cardboard. Colored pencil, pair of scissors, Fevicol, geometric box, and A4 size. A4 size, or you can write direct colored papers. Materials required. We are doing with papers. Colored papers. This will be your second point. Materials required. Aim, materials required. Then prerequisite. Prerequisite knowledge. Prerequisite knowledge. Where will you find this? This you will find in animation or simulator. Also will give you prerequisite knowledge. Here you can see this prerequisite knowledge. Area of square. These 3 points you will write 1 point, second point, and third point. Construction of right angle triangle. This is your prerequisite knowledge. Okay. Then you will write procedure. For procedure, again you go back to the procedure. Click here on the procedure, and you have two types of procedure. One is as in perform in the simulator, that you don't need to write. You have to do that one. But here in procedure, take a cardboard. So do not write the cardboard here, because we are not doing with cardboard. We are doing with paper. So we will take A4 size colored paper. Instead of writing this, take A4 size, cut any right angle triangle and paste it on the notebook. Notebook or paper. Suppose its sides are A, B, C. This is A, B, C, A, B, and C. I will tell you. Cut a square of side a centimeter, place it. So here actually A, B, C. So we have to give the values of A, B, C. Instead of A, B, C, we can take 3, 4, and 5 centimeters. Because 3, 4, and 5, if you will take the right angle triangle with the side 3, 4, and 5, it will be 5, and this is 3, and this is 4. So you can check 5 5 is 25, 3 3 is 9, 4 4 is 16, 16 and 9, 25. So right angle triangle. Then instead of taking this, you can take 3 centimeter, 4 centimeter, and 5 centimeter. Any three Pythagorean triplets. So take 3 centimeters or 3 inches. If you feel this is very small, 3 centimeter, you can take in inches. 3 inches, and instead of B, you will write 4 centimeter or inches, and 5 inches. That means, or you can say that take A is equal to 3 centimeter, B is equal to 4 centimeter. Aim is to verify the Pythagoras theorem. Aim, I will show you the space. 4 centimeter, and C, leave the space if you didn't write. I'll tell you. You can go through this video. You can have all the things later on. But a square of side A centimeter, a square of side A centimeter, this A centimeter will be 3 centimeter. You will write 3 centimeter instead of A, and place it along the length of along the side of length of the right angle triangle. Yes, this is right angle triangle. Here we are taking ABC. So this is hypotenuse. So we are taking this side 5. Then this is 4 centimeter, and this is 3 centimeter. So 3 centimeter square and place at this part. Then cut squares of B, that is 4 centimeter. Here you will write 4 centimeters and 5 centimeters. Okay, and paste like this. You can see here. I'm not going to move, otherwise this annotation will move to other way. So these three square, this is one square. Here we have paste. First draw the cut triangle, and three sides you have to paste like this. Okay. Then the same procedure you can write, draw the diagonals, this, that I will. So you know, no need to show the figure number. Color them, you can write color them only, name them only. That's that's it about the procedure. Okay, got it? This is your procedure. After this, you got the procedure. Okay, how to write I told you. Okay, then you can see the, you can go through the video, you can have everything there. Okay, now I'm going to erase this part. So we got the procedure, how to write the procedure. I told you what changes you have to make in the activity. Okay, so you will take the centimeters or inches 3, 4, and 5 instead of A, B, and C. Okay. After this procedure, you will write, next part is observation. After procedure, you will have observation. So observation you will not find here. This observation is a square and the four quadrants cut from a completely filled. Thus the theorem is verified. Okay, you can write this observation. we will see that what is the observation simulator. I will show you how to do it. Just let me see the final observation, then I will tell you how to cut and how to paste this one. Okay. One more line we should make. This is not placed actually properly. That's why it is going. We have to place it properly, perfect position. Okay. Double click on this parallel line to generate its parallel bisector. Okay. Select first. Now check all the check boxes in the toolbox to get 4 quadrilaterals. Select the first quadrilateral. Okay. Second quadrilateral, third quadrilateral, fourth quadrilateral, like this. We will select and drag. Now select colored pieces from the square below and height of the triangle and drag and rearrange in the square along the hypotenuse. These should be arranged here. This will be kept here, then this here, and this will come here. Okay, so this is proving that this area is equal to this area. So finally, we got this one. So the last, okay, so procedure is not that final observation is not given here. I think it is not properly placed, then this problem comes. So we will do that later on. So that means you have to write the observation. This one will be the observation. Observation is this one. Now this is very important that if you will cut properly, then you can have this proof. How I will tell you this observation you will write. That is the writing part. Okay, that's all for writing. And result you can write the theorem is verified. And the theorem is verified, or in the result you will write Pythagoras theorem. You can write it is verify that by sum of the square of the hypotenuse, Pythagoras theorem, you will write sum of, sorry, square of the hypotenuse is equal to, in a right triangle, Pythagoras theorem, in a right triangle, square of hypotenuse is equal to the sum of the squares of other two sides, of other two sides. This will be your writing part. Okay. Now we will go to the activity. How to do it? That is very important here, because here if you will cut wrong way, in the wrong way, you will not get exactly fitting in the square. So how we are proving and what we are proving, and we will do by animation also. We will do the animation also to show this activity. And for doing it also, you have to cut what you have to cut. Just we will have to see this one. Okay, now we go to simulator. First, we can go to animation. I will explain this animation. You can see this. To verify the Pythagoras theorem, AIM theorem is the area of the square on the hypotenuse of a right angle is equal to the sum of the areas of the square on the other two sides. Actually, this is a right angle triangle. So A square means side, square of the side will be the area of this square. So that's why we made you can see this animation, how to do it. Then click here, click here. Okay, this we will do. So no need to see this one. I think we will do it. So go to direct simulation. Now see here. This is actually hypotenuse. So what we have to do, we have to make these right angle triangle. You are taking, then this one is square of the, suppose this you have taken 5 centimeters, 5 centimeter, 5 centimeter, 5 centimeter, 5 centimeter, 3 centimeter, 3 centimeter, 3 centimeter square, and this is that is 4, sorry, bigger, 4 centimeter. This one you will take 4 centimeter, and this is 3 centimeter square. So you have to cut, first draw triangle and cut 3 squares, one 5 centimeter, 5 centimeter side, each side 5 centimeter, another each side 4 centimeter, and the third one each side 3 centimeter, and you have to place like this. Why? Because this side is 5, so 5 is square. This is suppose your A, B, and this is suppose C. So C square is the area of this whole square. That's why C square will be equal to A square plus B square. That is the Pythagoras theorem. C square is equal to A square plus B square. So that's why we are doing like this. Got it? So now we can see that how to do it. It is very difficult to make the exact figure. Here you can input any value. Okay, you can take any. So yes, whatever you are taking, that suppose here you are taking 100 and 50. Okay, you can change this range. You will change this range 97. It will change input box. So right angle triangle, it will give the right angle triangle always. So if you change this, check you are getting right angle triangle. but you can take some. Suppose I have taken this 5 and this is 4. What will happen? No, it should be 100 and so okay. So take 100 and 50. Take this 100 and this you can take 50 and then submit. You will get a triangle. If you need bigger value, you can have, but value is up to 100 only, so you cannot have more than this. Okay. So this is your right angle triangle. Then click on next. Then click on it. Here we have to make one triangle. Oh, sorry, one square with this side. Okay. So first you will cut one triangle with another color. Take different colors for each one. For triangle, take one colored paper, then draw a triangle, cut. Then see this side, whatever is this side, then you can make one. Cut one square with the side equal to this and with another color. Take different colors. Similarly here, similarly here. Okay. But this we need this one. This one, this below one, we need one more. One more square is required for this one. Okay, for this one. Understood? So you can make one more square. Why? Because we have to cut this and we have to fix in this one. Okay. Then this one also we have to fix in this one. That will prove that these two areas, sum of these two areas will be equal to this area. That will prove the theorem. Okay. So different colors. So take different colors. We will have different colors. Okay. Now draw the diagonals. Draw diagonal, but you have to make one more one more square in which you will draw the diagonal. But after drawing this, you have one line which is equal to this line and same line. We need the same line. The length of this should be equal to length of this, and this line to be fixed so that it should pass through the center and touches the 2 points. Like this, you have to draw. Okay. Then after drawing this, you have to draw the perpendicular bisector of this line. Just leave the lines below the diagonals, just leave. Here you will have to draw one more. Here you will draw one perpendicular bisector. This is what perpendicular bisector. After that, you will cut this portion, this portion, this portion, this portion, and this portion. So select first square. This is your first square. Then second square. This is your second quadrilateral. Third quadrilateral. So different colors, you have to take different colors. Every time you take different colors. So this we need one more square. And like this, if you have done some mistake in drawing this line, then this will not fit here. Now all these parts 1, 2, 3, 4, and this 5 parts we have to fit here. Okay. So drag and fit here. Okay. So from the 4 below base and square along the height of the triangle, drag them and rearrange appropriate in the square along the hypotenuse. We have to rearrange and drag them. Okay. Then this will be fixed here. This will fix here obviously. And this will directly fix here. Now in between you will find one square that is equal to this. We can fix this here. Okay. So this will prove. This is the observation. Yes, I was just looking about this observation. So here you will observe the entire area of the square along the base plus entire area of the square along the area of the square along the hypotenuse. Okay. Entire area of the square along the base of the triangle plus entire area of the square along the area of the square along the hypotenuse. The area of the square along hypotenuse is equal to area of square along base plus along. So this you will find the observation. There is something wrong here written. You can correct it. That entire area of square along the base of the triangle, entire area of along the area along the hypotenuse plus this is equal to, this is missing here, entire area along the base plus entire area along one side is equal to the total area along the hypotenuse. Okay. Therefore, area of square along hypotenuse is equal to area of square along base plus area of square along height. Hypotenuse is equal to hypotenuse into hypotenuse, base into base, height into height. Pythagoras theorem. This is the observation. So write this observation also. In that observation, you can add these points also. But cutting pasting should be very good, very colorful, and I will try to send you one notebook that last year that the students did, but they did very well. So understood this line. If this line is not perfect, these two lines, this cutting will not fix here. So for doing this, you have to make one line straight to this line. First make this bigger, and this line, straight line, you can have a ruler to get this line, and then bring that line equal to this line, and it should touch and pass through the point of intersection of their diagonal. Then another, you can easily draw perpendicular bisector of this line. Got it? So for doing it, I can do one more thing, but time is very less. I will yes. If we have a right angled triangle, this is our suppose right angled triangle, and we have to draw square here. Suppose this is our square. It is looking like rectangle, but okay. Then draw this diagonal, another diagonal. Now this ruler, you can use the ruler, okay, and keep the ruler here and at this point, and you can arrange exactly this ruler and length of this one. You can see it is coming exactly 6. Then do not move the ruler. Similarly, you can bring this ruler like this and just keep 0 here. This is the way. And exactly if you are getting 6, wherever you are getting 6, you can arrange this one. Same length should pass through the, so it is just somewhat you have to do. Keep this one and if it is 6 like this. Okay, then you can make the line. Okay, after this you don't need the previous one, so you take different color, then perpendicular bisector of this. So in order to draw the perpendicular bisector of this, we can use the compass at this point. At this point, draw one perpendicular bisector from this point. You can have bigger value. So here you can draw one arc. Here you can draw another arc. Then do not change the radius from this point. You can intersect these two arcs. So okay, so then again this arc is small, so we can make it big so that it should cut the other arc. Okay, so these two arcs, then we can join these two arcs. These two arcs. So this will be the perpendicular, exact perpendicular bisector of this point. It is not exact, but maybe we have done very fast. Then this portion we need to have the colors of this colored this portion, different colors of this portion, this portion, this portion, cut this portion. Another portion will be from this line here, then this portion, like this. You will cut the different portions and then fix on the above, where here you will find another big path. So that's why, so we don't have much time. So that's why we can, now this can be cut and fix this above square and this square. These all should be, but these two, this is square and these four portions should fix in this one, in this part. Then it is proved that it is suppose C, this part is C, then this C part, this is A or B, whatever. The C square is equal to A square plus B square, hence Pythagoras theorem is verified. Okay, got it?